Okay, let's get into this. So, I just check we are live. Yeah, it's still kind of laggy. I don't know why, but so this should be it should it's a array and it's going to be and it's inside of it it's going to be have a tensor address. Okay, so how we can set it this default. Let's just ask ChatGPT. Oh my god. 19. So here set up the f12 grad f12 what I said grad f12 some sort of array and this. Now how we can set this default. it no it is kind of it's kind of a here I have an array and it's going to have a reference for some other tensor. Easier to manage than lifetime, useful if you If you need shared, sorry for that, if you need shared ownership, slightly more memory overhead due to reference counting. Third option, if you are really want stack plus reference mix, rare not idiomatic unless you are interfacing with the FFI or need very tight control. Okay. If you want flexibility and no light and matter touch. So it's going to be a back and the RC tensor. So the RC thing, heap allocated reference with the lifetime assets. Mm, what you can do now? Hmm? Maybe we can do, but slightly more memory overhead due to reference counting. I think we don't want to deal with the lifetime thing. Okay, let's just, you will have to pass the lifetime when using the struct like uh, how I can pass the lifetime. And what this a thing means is a essential in Rust. Once you start working with the reference inside a struct, what does AM mean? It is a lifetime parameter. It tells Rust this struct contains reference that must live at least as long as A. So this struct contains reference that must live as long as A. Reference that must outlive lifetime. Okay, it means tensor struct borrows other tensors. Those borrowed tensor must live at least as long as the tensor itself. Those borrowed tensor must live as long as the tensor itself. How to pass a life? So how you pass a lifetime implicitly when you create the value in a function. Step by step. Create a two tensor. They live in the stock here. Stack, okay. Here. Store the reference to those tensor in another tensor. Okay. It's a base. Store a reference to those tensor in another tensor. Okay, I understand now. And then reference. But for that to work, your stock must have this lifetime. Full working example. Here we are creating stock, implementing, and calling k ref, but this slice live as long as the main. Hmm. You don't create a manually. Rust interface them for how long the variable lives. But in let me, if you don't want to deal with the lifetime instead of tensor, that way does Rust don't care about how long the data lives. You own it on the heap. Let's say in my case, my tensors and reference um reference having for other tensors have to live as long as I want. What I mean by that is this tensor implementation in a libgrad. So we don't have a main function. Main. And this libgrad going can be used by other libgrad too. So I want to keep the tensor struct and the reference tensor struct and the reference tensors if forever as long I say it is okay. Common use in a librarian. If you want a tensor to own or point to other tensor and you want a full control when they are get dropped, not by Rust, Barrow, Checker or lifetime function, best solution is this allows you to share tensors safely across multiple places, avoid lifetime entirely, control when get dropped, when function goes out of scope. So here we can call the, okay, we set it to this and some empty vector, and we are creating two set of tensors and tensor sending them clone that mean that gets an array and print tensor.get len. So shared memory, yes. Automatically clean up, yes. when the last RC is dropped. When the last RC is dropped. Okay. No need for lifetime. Yes. Live as long as you want. Yes. As long as RC is held. Multi-threading support. No. RC is not thread safe. Use arc if you want multi-thread. You can also use weak if you want to avoid circular reference. Okay, how it get dropped. Uh, when the last pointing to the value stop. Okay, here we have a and some B, drop A, reference count 1, drop A. The answer is drop. Yeah. The shorter answer is when the reference count goes to 0, the value stop. That's what we really want here. Let's just so okay, I know I need to know more about this because you know I'm not really sure how this work. I need to know how where it thing they said it's allocated in heap, so we need to know that as well. But for now, let's just get this demo working. Then we can now I think set it a empty set of thing. Okay, that's yeah. So rc.new. Okay, so now whenever we need to create, we need to use this rc.new, right? mm, and there is a lot of the things about Rust, you know, that doesn't make things simple. Okay, now we have this. So whenever we call this, let's say we have here we have a model, right? So then you have a model, and here we are creating this, right? The new embedding new actually is yeah. So at least in some place we are creating this tensor thing. Yeah. So now by the tensor. So when you call forward, so this thing, do we need this thing? Do we want to change this thing? No. We want to change not this thing, but this thing. Okay. But here the forward is basically taking some sort of an okay input length output so okay so taking self and where we are accessing the self. he ah here. So here we need to be careful. It's because so the tensor thing mm, okay, getting the slice representing the embedding vector. So we are getting the slice. For that, getting the slice. So we are getting the slice. Actually, it should be an it is it should be an mutable reference. Actually, do we need a mutable reference? So we don't need a mutable reference, but what we do need is when we're creating this variables, right? Actually, we need to set this to be mutable thing. So the actual data must be something like this. But I'm not sure this is how. Oh my god. This is how we can make this make the field mutable. Nope, invalid syntax. I am expecting that. So how we can do that? Correct way is to only the owner of the struct need to be mutable, not the field. Okay. So turns out works because tensor is mutable. Now it is so this is mutable struct. So we need to make the variable mutable here. Okay, that make a lot of sense. That basically proving that I need to learn more Rust. Okay, that's just basically fine. And when we are creating this, okay, here where we are creating this, so this is a self. It returns to something here, which is that then this should be meetable, and this also is meetable. Okay, now we can in backward pass. Now we can sorry for okay. So here we are creating another. So we are making we are basically doing everything fine, but there is a problem. So here after we cannot call this way, right? So we need to do something. So maybe we can do that sometime later. But for now, we have a tensor class. Now it's okay. Let's just start with the main implementation. Okay. So we have some sort of a thing. Let's just start with main. So here we are using any sort of thing. So main is still config equal to GPT config. That's it. Okay. So now I need to work on this. Here RC is RC. Okay. Okay, and the another thing I want to ask is that so I wonder the byte touch basically storing this gradient and weights, right? Is it in a stack or heap? Heap. Why this is the case, what it means. I know why it is the case and what it means. Okay, we got the answer. So it's in a heap, so we don't need to worry about. So this is how we need to create. See, and another thing is that first, so that's what making me sad is because we need to reinitialize them. Okay, maybe we can do that in a single line. Maybe we can do that in a single line. Basically, when we are getting this on a new data set, let's say here we can, what we can do is something like this. Basically, default default, and that's how he, look at this, right? Now everything's fine. So we don't need to worry about it. For here as well, it should be RC and yeah. Okay. This is what going to be returned by this forward. So we don't need to worry about anything. So if what here, once we create this is going to be created shape and set it the default. Everything is a default. Sometime later in the future we will set it to okay. Now we have to do something about this here, which is that now we have a, so basically here we are, once we got that, we are adding this, right? So this is basically come from here. So when we are adding those things, self and the our adjustments, we need to basically modify their, so here we need to retrograde stroke, right? Let's just retrograde stroke, sorry, and grad fn is going to be, it's going to be an address of, it's going to be a vector. So vac vac right, sorry, and it should be address of self and we need a mutable address. Self and a mutable address of RHS. That's it. and the grad, maybe grad is set to 0. Grad is basically, maybe we can set it to default. Hmm. Now it's bit more makes sense, right? But the thing is, when we are actually when okay, here we are calling this, okay, on this data, then this. The problem is these two, we need both of them as a mutable reference. Actually, we can get a mutable reference. Can we get a mutable reference? So for that, we need to have here, we need to get a mutable reference here, isn't it? So this should also need to take them as a mutable reference, otherwise we are not going to implement them. Once we call this, we need to set and the operation we are going to do. What are the operation we have to do? So now we have the actual reference, mutable reference. Now what we need to know is what is the operation. Maybe we can just set another field called right. So this should be something like, let's say str. We already let's just say it's we are making this string and operation, what we call this, oh, to string default need have nothing. So I'm not creating very optimized implementation. All I'm trying to do is get this work, get this thing work. Okay, so before we are setting this to a default thing, maybe you can is able to add That's it. Hmm. Maybe we can check this by making this both of them um, let's just use this in our main function alone. Then we can just say len dot x equal to c c c dot new, and it's going to be a tensor. What we need to set, let's say vec 0, let's say 5 comma 5, it's a size, and another vec it's going to be 5 comma 5 comma dot 0, no, it's 25 0. So, okay, now we finish this. Let's just run this. Okay, let me save this. I'm sure we are going to get a lot of error. Use tensor undeclared. Okay, it's tensor is RC undeclared. So where this RC package come from? RC is undeclared. Sure, we have some error. So these are module not found. Let's just make them all. Just keep them. So sorry for that. Use of unresolved module. Okay. Oh, did I? Okay, let's just put it in the source. Now we can use this. This is okay. This argument influences the return type format. Hmm? What do you mean by that? F2 found an integer. Sure, I'm making a lot of mistakes. Expected use size. Expected found an integer. What is the use size? Where you have found it? Okay. Expected use size. Tensor.new. Tensor.new. Have a use size. What do you mean by use size? It's a use size found an integer. But wait a minute. Then actually 5, it's not a use size. How can I make this as a use size? 25 expected use size. Font float. What I'm doing here? This should okay. Let's say make this as float and this is 25. Okay. Okay. Now I just basically okay. I messed up. Never using. Okay, now it's walk. Now actually we can print them. X dot print. Okay. And X dot, maybe we can actually print ln. So this is grad f. Let's just create another thing called y. So just change this to y and let's just create the variable equal to z equal to basically x plus y. So now when we print some sort of where is it? basically can z dot grad f1. Actually it's not f1, it's let's operator. Okay, let's just save this and let's just see what it tensor. Okay, so there is a problem with we cannot add RC tensor. So how we can add a RC tensor? What is the difference between normal tensor and RC tensor? RC tensor are located in the heap, and how we can add them? Let's just ask. No. How we can? Okay. This is my add trade implement the trade adding for my tensor. Now before we are not changing this to so this is the exact, actually this is the one field that actually change it to RC. Now we're creating this to RC tensor. It doesn't make sense is because why we are so just create as it is. And see unknown field. I do have a field called operate with some operation. Sorry for that. What is the problem? Recurrent. So tensor, you might have a minter field called recurrent whose type is your type. Expected due to the tensor font. Expected tensor. Okay, I have a whole lot of it. And this is my answer. And when I do something like x plus y, this this will be called right, but I want mutable variable of that, not immutable. Okay, immutable. You're close, but adding add trade require immutable reference. So, so your version is not valid. You cannot change the function signature of the trade method like that. So what you can do, you can store a reference directly. What we can do, okay, what we can do is um, again the RC tensor. Usage, creating this and this, call your this data. Why we are wanting mutable reference is because the mutable reference, because when we are in backward pass, when you are in backward pass, we need to make sure that the once we calculate the gradient, the tensor, we need to tweak the tensor according to the gradient, right? So that we want a mutable reference, not a immutable reference, is because if we want a immutable reference, then how can we change them? Maybe what I'm doing is what I'm doing is I'm not creating another set of memory. Like basically, these are the weights for forward pass. I'm not creating the another copy of backward pass. Another copy of weights for the backward pass. Once change them, then put it up, forward and backward. So the always you can see that there is two copy of things are maintained here. What I'm doing is once the forward pass is finished, I'm taking this memory and once it's finished, I'm taking this actual vector and calculating the gradient and change it accordingly and put it there, and calculating the another set of gradient and change accordingly. Because once you going backward, you can basically changing them, right? So that is what I'm trying to do. I'm not sure, but okay, let's do this. First of all, what is this RC thing? What is difference between this rec new and RC new. The global array. Creating a reference count, a smart pointer. Okay. It's a smart pointer. Creating a new reference count, smart pointer. Wraps a value. Shadow ownership. It doesn't clone. So smart. So that means it just increased the reference count, dropped by one dollar reference. To share a single value across multiple. Can we change and change the value using this RC smart pointer? There's a typo. No, you cannot directly mute the value inside the RC unless you are immediately like why is shared ownership and the rest prevents the mutation. Rust prevents mutation of shared data unless you are using safe wrap. Like right. Use STD. Cannot mute. How to mutate the value inside RC? Oh my god. Okay. There are so much things going on here. Yes, right. I want to clear them all and cargo one. The thing I want to smart pointer. When you add them, you need to know them. Okay, you need to have a mutable reference. It's because once you compute the gradient, you can change them accordingly. So okay. It's not a valid. So the correct version is 4C clone. So in score is when I do some when I try to add the vector something is x plus y, which is a tensor. It's a tensor. Now, in the graph, do I have have the mutable reference of them, or when you add a instantly, your resulting tensor does not hold the mutable reference to x. It holds immutable, but why? Then why ChatGPT told us it can do something like this? So if truly want to mute out the data, for example, when the common pattern receives the combination of yeah. Okay, here the data is, so we need to make this wrap the data in our RFCL. This is the best way we can do this. I just forgot to type way. Oh my god, it takes so much time. I think today as well we are not going to complete this. It takes for a while. It's going to take some time. Excellent question. Whether this is the best way to do it depends on your goal. I know that. User-friendly tensor is now cheap to clone wrap. So what do you mean by that? For a learning project to understand the fundamental difference, your current implementation graded identity and a safe start. You have a correctly identified that computation and have used the tensor to model the shadow. This is the right, but how this means more crucial issue mutability for gradients. Because the limitation of your current design is that it cannot actually perform the backward pass by calculate gradient, which involves accumulating values in the gradient tensor. Your tensor structure has no grad field. No, I have that. See, this is kid grad, this is for grad. No, I have that. Didn't I? See, no grad field, and even if it did, gives you the immutable access, so you cannot update it. So this is the concise canonical rust pattern for graph. So when you need to modify the nodes, so Okay, it's a common practice to have a inner struct that holds the data and the light wrapper holds the RC. See, the user-friendly tensor is now cheap to clone. Creating a new inner tensor. Cloning shape can be small. Can you explain this code? What you are doing now? What you are doing? You are creating a struct called tensor in dot shape data grad grad, and you are basically to cloning that, working with the RC, working with the RC. Working with the RC tensor everywhere is a verbose. By creating a wrapper structure, you can hide the RC and provide a much cleaner API. What do you mean by that? So by creating a wrapper structure, you can hide RC and provide. Okay, here. So, so, oh, let's once you add this, once you add this and the data serve, once you add this, okay, once you add the data, then recur the grad flag should be true if either recurs grad. So let recur grad equal to self should be true if either. Okay, that's fine. And creating a new inner tensor. So let inner equal to, we are creating a new, the inner tensor inner shape dot clone. Note, cloning shape can small cost. Data either initially if draw else Return the new proper tensor. So, so you are saying that if I use x plus y, then in and say it to z, and now the z tensor field d tensor field grad fn to have the mutable reference of the x dot data and the y. That is what now what we want to do. Okay. Okay, I think we are running out of time, so that let's just no, that's crucial distinction. Thank you for hosting. Okay, I think it's going to take bit time, but try our best to give what we got. Pretty soon we will finish this project. Okay, thank you for watching. Hope you learned